All right, guys, today we're going to perform operations with complex numbers. Complex numbers are numbers that have an imaginary portion, so you're going to see a lot of little i's today. First of all, the square root of a negative number. That's where imaginary numbers come from. If r is a positive real number, and you do, well, take the square root of a negative number, you can take the square root as long as you pull an I out. I is the square root of -1. So if you break the like this example right here, if you were to break the -3 down like this, like square root of 3 times the square root of -1, which would be square root of -3. Remember, square root of 1 is I, so it'll be I on square root of 3. If you square it, if you were to square I on 3, like that example says right there, you would square the I and square root of 3. And remember, I squared is really -1 times 3, which is -3. So remember, I squared is -1, I squared is -1, I squared is -1. That's very important. There's a few kinds of problems you're going to see today. They're going to give you quite a variety, actually, in this lesson. So let's go ahead and get on them here. First one is just solve an equation. As you move the 11 over, watch what happens. The -37 becomes -48. If you divide by 2, you get -24. But that equals x squared. And to get rid of the x squared, obviously, you got to take the square root of both sides. And imagine that. You have a negative square root. So first thing I'm going to do is pull the I out and make it positive 24 inside. But then don't forget, you got to break that down. Also, don't forget, you got to put your plus or minus, like I just then forgot. 24 is really 4 times 6. So I'm going to put plus or minus. The square root of 4 is 2. Bring the 2 out. The I is out. The 6, you don't know what the square root of 6 is. It stays in. And there's your solution right there. Plus or minus 2i on 6. So the same thing we've been doing earlier with square roots, except now they're going to be negative today. A few big words here. Complex numbers encompasses every single number there is. Real numbers have no i's in them. Numbers like -1, 5/2, pi, square root of 2. Imaginary numbers have a component that is an I. So like this is what, when I hear the word complex number, I'm thinking this usually, 2 plus 3i, 5 minus 5i. They're called pure imaginary numbers if there's no real part, like just a -4i or just a positive 6i. Those are known as pure imaginary. The next thing we're going to do here on the next slide is we're going to add and subtract them, complex numbers. And really all you do is you add the real parts, add the imaginary parts, or subtract the real parts, subtract the imaginary parts, and put them back together. No big deal. Let me show you a couple here. This is write the expression as a complex number in standard form. All I'm going to do in this first one is I'm going to add the real parts, 8 plus 5. I'm going to add the imaginary parts, which is -i and plus 4i, and get positive 3i. And that's it. That's all you have to do. Now the second one has a minus sign. Got to be a little more careful here. My advice is go ahead and distribute the minus sign through to get your signs correct, like that. Then add the real parts, which would be 4. And your i's, this time -6i and positive 6i, are going to cancel, so you just get 4. Which is fine. And the last one right here, again, we have a minus sign, so I'm going to distribute that minus sign through. The 4i at the end does not apply to that. So 10 minus 6 is 4. I have a -7i and a positive 4i. That's just -3i. And there you go. Not bad at all. Multiplication is going to add one to more dimensions here. The first one is just 4i outside. You're going to distribute the 4i. So if I do 4i times 6, it's -24i. If I do 4i times just another I get 4i squared. You're never, ever allowed to leave an I with an exponent in an answer. So don't forget, we talked about a minute ago, whenever you see I squared, it's really -1. So this second term is really 4 times -1, which is -4. And technically I'm done, but technically I'm not, because when you write a complex number, they always want the real part to come first and the imaginary part to come second. So make sure you do that. And the second one here on this page, I'm just going to do FOIL like we've been doing all year. So if I do first, it's -36. If I go outer, it's 63i. That's those two. If I go inner, I get plus 8i. And if I go last, I get -14i squared. And again, I'm not done because a couple of things. First of all, I can add the 63 and the 8i, which is going to give me 71i. This I squared is going to make it be a -1 times -14, which gives me a positive 14. Just changes the sign on the 14 is all it does. Now add the -36 and the 14, which is -22 plus 71i. And that's it. All right, this is probably the hardest thing today, so pay close attention to this one. It says write the quotient 7 plus 5i over 1 minus 4i in standard form. Now to do this, you got to treat it like we did radicals earlier. You have to multiply by the conjugate of your denominator. Now the conjugate of 1 minus 4i is 1 plus 4i. So I'm going to multiply the top and bottom by 1 plus 4i. Now your denominator, because they're conjugates, remember the shortcut you can do, you can just do first last for conjugates. So if I do 1 times 1, that's 1. Negative 4 times positive 4 is negative 16i squared. There's that one. And I'll go ahead and finish the bottom. That I squared is going to make that 16 become positive 16. So it's really 1 plus 16, which is 17. And there, I don't have an I in my denominator. That's the reason you have to do this. Remember, I technically is a radical, and you're not allowed to leave a radical in your denominator. Now on the top, my numerator's here. I have to do FOIL. So I'm going to do first. If I go outer, I get 28i. If I go inner, I get 5i. And if I go last, I get 20i squared. And don't forget what all that does. 28i plus 5i is 33i. And because this is an I squared, that's really a minus 20. So if I do 7 minus 20, it gives me negative 13. And now you're done. You need to look and make sure you can't reduce that any, and that one you can't. So you're fine there. Okay, a couple more quick things here. It says plot the complex number in the same coordinate plane. Now, when you're doing complex numbers, instead of an x and a y axis, we're going to have a real axis and an imaginary axis. The real axis is what the x-axis used to be. Imaginary is what the y used to be. So if I'm going to do 3 minus 2i, I'm going to go 3 to the right, down 2. There's my point. If I'm going to do negative 2 plus 4i, I'm going left 2, up 4. There's my point. Part C is just 3i, so I'm not going left or right at all, just going up to 3i. And if I'm going to do the last one, negative 4 minus 3i, I'm going negative 4 on the real, down 3 on the imaginary, and there's my point again. So very easy right there, I think. All right, last thing, absolute value of a complex number. Remember, absolute value means how far a number is from 0 on the number line. Well, if it's a complex number, it's how far away it is from the origin on the coordinate plane, the real and imaginary axis. So if they give you a point or a complex number, they want to know how far away it is, like right there. So if you look at the picture, it makes a right triangle, which means you can do Pythagorean theorem if you remember from geometry. So that's what the Pythagorean theorem looks like. Absolute value is going to be the square root of a squared plus b squared, where a is your real part, b is your imaginary coefficient. All right, so here we go. Let's try a couple. The first one, I want the absolute value of negative 4 plus 3i. Now watch how simple this is. All you do is use square root. You square the a, which is that negative 4. So I'm going to do negative 4 squared. You also square the 3, not the I, just the 3. And you would get 16 plus 9 inside, which is really 25, and the square root of 25 is 5. So the absolute value of that first term was just 5. Let's do the second one. Absolute value of negative 3i. So how far is that from 0? That should be pretty obvious, actually. But you would do this. There is no real part, so it would be 0 squared, and then you'd have negative 3 squared, which would be inside. You'd have 0 plus 9, which is just square root of 9, which is 3. And that should have been obvious because negative 3i is like right down here on your graph. So they're really asking you how far away is that from 0, which is there, so it's 3 away. All right, that's quite a bit of stuff. It's not hard stuff, but there's a bunch of different skills in that lesson. So hope you got good notes. We'll work on it tomorrow like we always do. See you then.